speaker is Olaf Reuter von Matrix Vision, and he will talk about the expressway to embedded vision. Mr. Reuter, it's yours.
Thank you very much. Something going? Yeah. There's a little delay. I'm sorry for that. Matrix Vision, a traditional German camera manufacturer founded in 1986 with a staffing today about 120 people. We are 100% daughter company of Baluf GmbH, nearby here, behind the airport, with about 3,000 employers. And we are the responsible company for everything what's around vision, camera technology, inspection, customizing, etc. We have a lot of competencies in our company. Engineering, which is the main factor for everything what we like to do, to realize your solutions to satisfy your customers and your approaches. We have a very strong team which is famously experienced in integrating sensors. Not only Sony, we have also other suppliers in the portfolio. We are since decades in camera interfaces experienced, as well as in software and firmware development. In the past, we developed several embedded systems, smart cameras, etc. So we are also capable of adopting Unix, Linux-based systems. We are experienced in handling different operating systems as well as all what the customer is demanding. Coming to your solution, and I like to bring you a little bit in another mood. What do people think about embedded vision? Is it something famous, new, completely different? Is it something which brings outstanding performance for very less money? Or is it something what's absolutely famous because it uses artificial intelligence? No, it is still the same as it was in the past. It is a computer vision system as an integral part of a machine or a device to solve one specific solution. One could say in this embedded system, a camera is just a simple and stupid module. No, that's not the case. We have to take care that the camera and the camera pixel and the camera behavior fits the demand of an application. And the basis of a robust vision application is still a good image with a low latency. The perspective of a machine vision integrator, and that's our customer. He wants the flexibility he knows from the history, from the historical machine vision camera with the traditional interfaces like USB 3 vision or Gigabit Ethernet vision, the flexibility of a whole family with different sensors, the compatibility with standards as GenTL and so on, and also the ability to quickly port his application into this new embedded world. And he needs the capability to deal with all the effort which is created by embedded systems today. Our answer to that is PCI Express, which is a transportation interface for data designed for the internal communication of computer components. It is well established, as you know, each and every PC has PCI Express on board. It is highly scalable. It is secure. The protocol is always the same. It supports DMA and GMA. It is extremely flexible, and it can also be carried on cables, which most of us do not know. In data centers, PCI Express communication is based on copper cables as well as on fiber cables, and this technology can also be used to interface cameras. To introduce our expressway, we see here the pictures of our camera family, Blue Naos. There are two kinds of these cameras, a Blue Naos 2 model, which integrates sensors of this generation, Sony generation 2, as well as a Blue Naos 4, which interfaces the brand new Bridges S sensors with the of the 4th generation with the SLVS EC interface. On a later page we will see that. Also we have two flavors. One flavor is the connection via a flex cable, and the other flavor is the connection with a so-called OcuLink cable. Here we see the 13 sensor types. Some people say you can present 26 models because each of these 13 models is available in black and white sensor as well with a color sensor. And in the graphic we see the sensor types of the SLVS integration and the other the EC integration. Main facts: we integrated PCI Express Generation 2. And the camera contains an FPGA which realizes the same image signal processing pipeline as we know from the traditional machine vision cameras. So that means these cameras do an onboard deburring in a 5x5 matrix, for instance, or you can apply lookup tables directly in the front end. What this camera modules not contain is memory. So all the streaming from the sensor lands immediately per DMA in the main memory of the host system. Due to PCI Express, we support also the x86-based systems, while MIPI CSI mainly supports embedded ARM-based systems. Here in detail, something about the interfacing. You see the flex cable. On the flex cable, we carry everything what's necessary to bring the camera alive and to interface digital I/Os as well as serial interfaces to control fluid lenses or something else. I like to make you aware of this OcuLink interface. The OcuLink interface is based on a copper cable. We can reach up to 1 meter distance to the embedded target. Interesting is there are the small form factor standards describing the connector as well as the cable. And a little drawback is, sorry, this cable is not providing power to the camera module. So for powering the camera module, we have a second connector based on a small Samtec type, which gives power to the camera as well as integrates the GPIO lines here. Brand new on the right side in the image you see adapter board, which was designed for the brand new NVIDIA AGX Orin system on modules. These modules have the strongest power in the NVIDIA portfolio at the moment, and this module sits on the carrier board. And below of the carrier board there is an interface board which provides you 8 channels PCI Express version 2 with 4 lane to carry up to 20 gigabits per channel. Physically is it based on this OcuLink connectors which we see on top of the board, and on the bottom of the board we have M.2 slots, key M, for camera adapters or for SSDs or whatever you need. So, as probably customers know from our portfolio, all our cameras can configured by a nomenclature system. So you can order each and every camera in the embedded portfolio without lens holder, with M12 lens holder, with different interfaces and so on and so on. And the graphics here explains how you can configure the camera of your needs. That means we do not do a customizing, we just configure a camera or a camera module or just the front end on a certain nomenclature, and all these variations are available off the shelf. Processor platforms. In the embedded world, very popular are the different kinds of ARM platforms. But as I mentioned, even the x86 systems getting smaller and smaller, and they are also available in the embedded world. May you have heard about ComExpress module, system on modules and similar things. All these targets are supported by our PCI Express technology and our PCI Express camera modules. If you come to our booth in this hall, C30, you can see different of these samples of such computer boards. There is a single board computer with a 60-core ARM processor, or there are also others. Just as an example, how we can interface these PCI Express camera modules to different embedded computing targets. From the software point of view, I think people who work in the embedded business, they know Video for Linux or GStreamer to grab images via standard camera modules. We extended that approach. We provide for each and every interface technology GeniCam transport layer producer, which is shown here in the graphic. And on our booth, you can also see a demonstrator which shows how we interface Gigabit Ethernet, USB 3 Vision, our PCI Express technology, as well as the MIPI CSI technology on the same GeniCam compliant way. GeniCam, may you say, is not interesting for me, but for people who like to port from the traditional PC based computer vision systems to embedded computer visions, for them it is very beneficial to reduce time and to reduce risk of porting the application. At the end of the day, I like to make you aware we are supporting some evaluation kits, so get in contact with our sales. We will help you to solve your embedded application, to create or to build your embedded solution. And as I mentioned, we have a lot of competencies in our company. We have more than the half of all our engineers working every day very hard in realizing all this, what we have done and what we will do in the future. And the approach is we like to collaborate with you as customer to realize your embedded solution with lowest time to market and with lowest risk for your activities. So we are strong in hardware, software, operating systems, as well as in applications. Thanks for your attention. I'm 5 minutes too early, so we can catch up with the time schedule today.
Yeah, great. Thank you for this interesting lecture.
Thank you.